Okay, so there have been several questions coming in about the colligative properties homework. So I'm going to run you through 3 examples. This is for number 1. Number 1 and number 2 kind of work the exact same way, except for number 1, we are doing boiling point elevation. So that means that 1 mole is going to increase the boiling point by 0.52. I don't have it memorized. I have to look. And like I said, that's not anything you have to memorize either. But so here's how it works, right? So let's look at number A. For number A, we have 1 mole of C2H4O2, and this starts with carbon. This is carbon-based, right? So we have 1 mole of it. It is carbon-based, so that means that it's a molecule. It's covalently bonded, and none of these things break apart when it goes into solution. So 1 C2H4O2 will make 1 particle. So if we have 1 mole, each substance makes 1 particle. How many do we have in all? 1. So that means that our boiling point will increase by 0.52, and our new boiling point will be 100.52. You guys follow that? Now this one, this is an ionic substance. How do we know? Well, it doesn't start, for us, it doesn't start with carbon. We have a metal and a non-metal. It's going to be ionic. For us, it's going to be, if it starts with carbon, that's going to be your covalent bond. If it's a metal and a non-metal, for us, that's going to be ionic. So here's how this works. We're starting with 2 moles of this stuff, right? So we have 2. Now each calcium chloride is made out of 1 calcium and 2 chlorines. So how many, so because this is ionic, it'll break apart when we put it in water, when we dissolve it. So if there's 1 calcium and there are 2 chlorines, how many ions do we have in all? You got it, 3. So it works like this. We have 2 calcium chlorides. Each calcium chloride makes 3. How many do we have in all? You dig? Right, it's going to make 6 particles. So we take that 6, we multiply it by 0.52, because there are 6 particles. Each mole of particle raises it by 0.52. Our new boiling point will be, let me math this one out. So what is it? 6 times, ooh, I should turn it on. Oh man. Guys, you know, it's one of those days. 3.12. So my new boiling point will be, you dig how that works? Oh, there you blurred. There you go. Are you guys following me on that one? Now this one, number H, this is one that's like, this is one that throws people for a loop. It all works basically the same, right? We are going to start out with, let's do this one in orange. We have 3 moles of barium nitrate, so there are 3 of them. How many particles does barium nitrate make when we dissolve it in water? A little blurry there. Let's see if we can unblurify. So look, we have 1 barium, and you see this? You see how there's like a capital B, a capital N, and an O, and a capital O. Guys, if there's more than 1 capital letter, we have a polyatomic ion, right? So NO3 is your polyatomic ion, and it's right there in your reference chart, that whole table of all your polyatomic ions. You won't be responsible for anything other than those. Got it? So you will make 1 barium. You will make 2 NO3s. So do you guys see how there are 3 ions here in all? You know it's ionic because it's a metal and a polyatomic ion, therefore it's ionic because, you know, it's an ion. So 1 barium, 2 NO3s. How many particles or ions do we make in all? Yep, 3. So if we have 3 barium nitrates, each barium nitrate makes 3 dissolved ions. How many dissolved particles or ions do we have in all? That's right, that would be 9. 9 whole new particles. So let me do the math. 9. 4.68, so my new boiling point. 104.68. You dig? Now for number 2. Number 2 works exactly the same, guys. The only difference is that for every one for every mole of dissolved particles here, if we're talking about freezing point depression, instead of multiplying it by 0.52 and adding that to 100, we are going to multiply it by 1.68, and we will subtract that from 0. So this would be minus 1.86, like negative 1.86. This 6 times 1.86, and whenever that is, it's negative that number. This 9 times 1.86, your new freezing point is whatever negative that is. You guys dig?